Hi, I'm Stuart Corbishley. You can find me on Twitter there. And I recently joined the guys at CLO. Previously I was involved in the Gauteng Online project, that massive schools project. You can Google about all the bad press now. Yeah. So today I'm going to be talking about abstracting a service, an elaborate show and tell and forward thinking with service-oriented architecture. When I started doing the talk and proposed it, case study sounded like a good word, and I realized that I can only show you scars. So basically, here's the situation. We have our current existing application on the left. I'm going to nickname it Big Store for likeness reasons. It basically is a massive, hairy Rails app with 40 gems, dependency, STI, weird polymorphism gems. It's had like 8 contributors on it. Some are no longer with us. Yeah, but two main things that stuck out for this application is that it managed users. Easily over 1 million users. It managed Linux passwords, keys, accounts. It was a fairly sophisticated and a very core part of the project. And it also, more recently in the last year, has started managing devices, things like tablets, cell phones. A user would come and install an app on their cell phone and then type in their username and password that associates with our system, and it would store their IMEI number, and they're registered and then do all sorts of wonderful and horrible things. So this app, as I said, it was big and scary and very, very important at the same time. So along came a new business case. Lined in panic, as the illustration points out. So we had a new customer who wanted to merge their users, and they wanted to have their devices managed by application. They really liked the way it works. And we're like, awesome, new business is cool. People like our stuff. That's awesome, and that's what the business owners told us. It's not quite the same when you're actually working on the system. And we actually realized it wasn't that cool. It really didn't work for us. We didn't want the new business. I'm not a shareholder. But as a systems architect and someone who wants to be proud of their application and stuff, you want everything to be cool. You want it to be great. You want it to go sleep at night. You don't want New Relic alerts and all sorts of prowl and all these other things annoying you. But there was a massive constraint. They already had users, a lot of them as well, and they saw a portion of our application as a product. But obviously, it was a portion of the application. It's not its own separate thing. They're actually not technically compatible. So we knew, in order to facilitate this new business case, we had to do some refactoring. We didn't really want to make a big mess worse. So we started thinking about, how can we refactor this? Cleaning up one application is not really going to help us in this case. We need to make room for new business cases and not just make our application cleaner. So we started thinking about service-oriented architecture and how it could help us. So I know Jacob yesterday described everything that my talk doesn't describe, so that worked out pretty well. But I'm going to re-describe what service-oriented architecture again is. Blah, blah, blah. Designing and developing software in the form of interoperable services. And at least my pronunciation was spot on. I could not say that about 6 times outside 10 minutes ago. Thank you, Wikipedia. But what does that mean for us as developers? It means reuse. You are inherently going to be reusing more code because you've got different applications. Copy paste maybe, but hopefully you guys are using gems. And you have the ability to compose new applications from existing applications, and like a hot wrench through butter, smaller applications are easier to maintain. Upgrading Rails apps with 40 gems, how many people have a 2.3 app they can't upgrade? There's more than that, I'm sure. You guys are lying. So let's pretend we went ahead and did what I said we shouldn't. This is what it would look like, our existing system. We'd have the new users in there. And we'd have a link table. We'd probably have some STI. If we wanted to be an asshole about it, we could throw some polymorphism and some weird mixins, and just really just make it worse. You know, it would feel fun. You know, it would, you know, it might meet the business need, but it wouldn't make things better for us. You know, the team, we'd be still working with a test suite that takes 15 minutes, and you know, so how do we go forward? How do we not have a one-to-many relationship with shit? So, what does this look like? This is what we described to ourselves as a better idea. We patted ourselves over the back repeatedly before we did any work, and we have three. What you're basically looking at here is three applications. You know, our user base looks exactly the same as it did a year ago. It doesn't have devices in it. The idea was that we'd split devices off into their own applications so that devices, regardless of where they're associated, could be stored. And then we still needed to maintain the rules that were very specific to one user base about who can and who can't and how many devices they can associate. And we decided to keep that in its own application. So, the rules are stored in the middleman. It's kind of like a link table. It has validations and all that stuff over there. So we have two problems we need to solve. We need to maintain login. We decided to have our clients, the front-end devices, would now talk to our new middleman app, our big store devices link table middleman application. We needed to maintain login. And as you can see from the little diagram, there is actually technically now a system boundary. We're going to log in, and then log in, you know, big store devices doesn't know how to log in. It doesn't care. We don't care. It shouldn't care. So it's going to go and speak to the other system, authenticate, and yay or nay, the response comes back. The other thing we need to do is actually register devices. Our existing functionality, everything worked before, so we actually kind of need to re-implement it. You know, refactoring is a nice word to describe it, but we actually had to do it again. So the process was, with the system boundaries, a request comes in to register, retrieves their user information about the user in question. It finds a device with that IMEI number, does some validation, can they, can't they, either create the device or not. So this is what my coworker Glenn described as a better quality of problem. It's still a problem. It's still work. It's still something that has to be done. So first things first, what does that look like? Well, we first thought about, well, let's fire up some Rails apps. So the rest of our infrastructure was Rails apps, and so we thought, Rails is a bit heavy-handed for this. I mean, these apps are doing very, very little. So we created two Sinatra applications, and obviously the implications of abstracting a service has massive effects on the implementation. Your implementation does not look anything like it used to, at least when you start out. Ruby has piles of tools for making things really, really great, and that's why we're all here, and why we're still here, and why we were here last year and the year before, and so on. So there's a couple of gems and a couple of libraries and a couple of things that we discovered along the way that really, really made everything easier. They really stuck out for us. So the first thing I'm going to talk about is message passing. Our classes need to be able to communicate. They need to be able to communicate the way they've always done, or at least be able to achieve the same end result. So REST in the Ruby world is so easy that using anything else doesn't make sense. And that said, basic HTTP clients in their rawest form are painful. They offer no advantage over things like Active Record or Mongoid or any of these object relational mappers. So we found a gem called Her. Although awkwardly named, she is very wonderful. Her is an object relational mapper based on Faraday. Faraday, I don't know, probably some of you guys have probably used it. It's a wonderful HTTP client that wraps around other HTTP clients to solve the problems that I mentioned earlier. Her has an active record-like look and feel to it. It infers URIs based on class name. It has the ability to map relationships with other Her objects. It is rather limited compared to Active Record. Obviously, you know, we're not talking, you know, Gorby Puff awesome. You know, it's just below. However, because it's using Faraday, we get middleware. We get the ability to prepend and append and interpret requests however we want with our own modules. And this became absolutely invaluable. That said, you know, we can't have our classes just talking out in the open. We needed some sort of authentication. We needed to also fit in with our existing authentication system. we didn't really have a central auth server. And really, during a refactor of this size and of this very real time constraint, we didn't have time. You know, like, it's all nice to think about it and talk about it. We actually just had to do it. But we thought, well, we have this big store application. It's a Rails app. It's got Rack. It's got some HTTP basic auth. It's got forms. You can log into it. There's nothing stopping you. So we thought, well, what's the difference? What's the difference between an API at this level? What is the difference between an API key and a cookie? They're really pretty much the same. So our initial plan, I would not advocate this. Don't do it unless you have to. But first step is a user tries to authenticate. The login API at big store devices forwards the request as is, unmodified, to our user repository. Our middleware then grabs the response, grabs the session ID that Rails allocated on users, and then stores it in the local session store for that application. So while that user is logged in and authenticated, every request to the user's repository after that would be adorned with this session token that came from the user repository. And this actually worked rather well, considering that we had middleware. We used the Faraday middleware to do this. So we were able to, that when we eventually come around and we have this auth server and all the auth key security and stuff like that, we can literally pull the middleware out and drop in some new ones. Very, very, very straightforward. The next aspect with service-oriented architecture is object uniqueness. Very, very simple systems, you're not going to have, you might not have objects that relate directly to other ones. They're going to be completely decoupled and completely blind, which is great. But every once in a while, you need to make a relationship. You need to show that something belongs to something else. So that said, storing keys and storing information from other systems tends to be a bit of a problem when using relational database ID columns. They are going to overlap, especially if you've got two different objects of the same kind coming from two different systems. Why you'd be in that position, I don't know, but these kinds of things happen. So you need to be able to guarantee uniqueness, and there happens to be a gem for generating UUIDs that we used. It was great. It's very, very simple. The GitHub page explains exactly how I did it. What we did is just to all our classes that were going to be exposed, we added a UUID column and added before filters on active record, and all our new instances got their own UUIDs. And then we made a rake task to retroactively fill in the backlog. And the next part is testing. My favorite part of this whole little journey that we took. There are two gems that we used quite extensively. Some of them you guys might be familiar with, and that's WebMock. If you haven't, WebMock is a library for stubbing and setting expectations on HTTP. What it does, it supports a whole bunch of HTTP libraries, Patron, Typhus, and a whole bunch of other ones. It hooks into their stacks and basically allows you to, just like with RSpec, expecting this HTTP transaction to go through, and allows you to mock out stuff and get predictable item-potent tests. That said, still testing HTTP stuff is still kind of painful. If you're using WebMock, you're going to have to stub everything out unless you're going to have real servers running. That brings us up to my next point. If you've got six or seven reliant applications for your test suite to run, that's a lot of Rails S. That's a lot of rack-up commands, and that can be alleviated with things like POW, but it's still not enough. You want your tests to run quickly. You want to be able to move through an entire test suite really, really quickly. So the next gem I used was VCR. VCR allows you to get around a lot of this stuff, and it solves the problem with item potency. If you can't get data into your external applications, into your development instances that are running all over your system, VCR is a really good way of doing it. You can set those applications up to be in a certain state and run your tests and get your expectations back. So what VCR does, I should have explained that first, but VCR, what it does is that it records all HTTP interactions through WebMock or another HTTP client. And then when that URL or when that request is hit and matched again, it will play it back, which is really, really useful. And That said, though, it should be used with caution. Making expectations on the interfaces very, very early can be very, very dangerous. So this is what the stack of gems ended up looking like. All of our applications ended up having this little suite kind of coming across and going between them. And it was really, really useful. And you could tell these maintainers know about each other and they're working together, and these gems fit so well together that it's not a coincidence. And that's something really, really great to see. This particular stack of gems saved us an enormous amount of boilerplate, and it was just a really, really great experience. Key learnings. It's all object-oriented. It's all OO. Like everything that you know about object-oriented programming still applies. It's just you're zoomed out. So go with your gut. The next thing is choose your partitions wisely, and not too early and not too granular. You don't want to be in the position where you have to put an application back together because the development pains are worse than the gain that you achieved. Don't partition for the cool factor. I know that when I first started on this, I just wanted to just split everything. You know, why do we even have a models folder? It should just be the name of the application is the name of the model. You know. So the next thing you want to do is let the customer's requirements drive the abstraction. Often you'll find with service-oriented architecture, developers get carried away. The cool factor applies. It's really fun to do this stuff. It's really fun to see everything gel and all the parts moving together well. It's a really cool thing to see. However, customers will always know more about your domain model, always. And I think sometimes we tend to forget that. As much as we might tell each other that, we do forget it. So customers are really, really good at showing logical partitions. They talk about a system on a much higher level, and by listening to those parts about the system that they feel are different, that's a key point to start thinking about your services. Next point is you want to minimize cross-service joins, and by that I mean services talking to other services to retrieve information. Joining data over HTTP is really, really expensive, and it's not too difficult to get a particular function or a report to be built that requires a couple of thousand or tens of thousands of requests. Obviously, that's not going to take seconds. That's going to take minutes or hours, and it's just not efficient. This particular problem is a problem in it's a talk of its own. As something that we used to help minimize this was redundancy, using data stores like MongoDB and Elasticsearch and stuff, and using object stores where you can define your own schema at will is really useful way of combating this problem. But that introduces its own set of problems as well. This really applies to all programming, but when it comes to dealing with HTTP and REST services and web servers and all that stuff like that, the hurt is double. If you don't commit and put a line in the sand about this is what this interface is going to look like, it's going to suck. Like going through your stubs and all your mocks and stuff like that, and changing them and working out what they are, sitting in the command line with curl running repeatedly is not great. But as always, documentation is king. And yeah, so I advise everyone to read this book. It's a fantastic book. It covers everything that I've covered and a lot more as well. Paul Dix's service-oriented design with Ruby and Rails. I have not been paid to say this. I own the book, and it's just great. So yeah, smash your app into little pieces. Thank you. Any questions? So, sure. Okay, yeah, maybe I should have actually covered that in the talk. We use Nexutra, you see last year, who does the raw gem. He's got a gem called Representable, which is a really good way of mapping. It's a lot like JBuilder, actually. personal preference. It's a lot like JBuilder. We use that to expose what our documents should look like as they're going across. But her, on the other side, has, because of the middleware, allows you to throw middleware and to detect content type and to treat it accordingly. Like Rails often passes its documents across, if you just use it as is, passes them nested inside a key of the object type, which is kind of actually a little unconventional when compared to other frameworks. I don't know which one's better or worse, but there actually is a middleware that comes with her that is explicitly designed to do that. So if you've got a web service that doesn't structure its document the same way that Rails does, you can change it. So you have a lot of control. Yeah. Any other questions? Yo.
Did you consider using URLs instead of UIDs? Understand what I'm saying?
Like hypermedia style, kind of pointing at something, using that as your identifier.
Giving an ID to something, give the URL to that thing.
We did not, no. That's actually a really, really great idea. Well, how do you deal with change with that?
Well, it's the same resource,
Yeah.
right?
Yeah.
So you end up having your ID in the URL.
Yes.
You violate your constraint by closing your database ID because you're just going to generate a URL that has a database ID in it.
Yes.
But the URL is not just an ID, it's an
unique
ID at a location.
At a location. That's a great idea. That's better. Any other questions? Yes. Thank you. We haven't had enough throughput on this new system to encounter that. As I said, we are using Elasticsearch and stuff as our kind of our chief aggregator at the moment. For the device management system, Elasticsearch is kind of the go-to place to ask questions. So usually things get in there quickly enough, or it's responsive enough that we don't really have a command on a document or a change on a document won't happen unless it can be found in Elasticsearch. And Elasticsearch is the last place that something will be. So for that kind of case, it's taken care of. But yeah, I guess you probably would run into eventual consistency problems. Yes, absolutely. Elasticsearch, however, obviously scales out horizontally magically. I can talk to you about it later. It literally is almost without you asking it to do it. It's actually annoying. Yeah. Any other questions? No. Thank you.